All right, so rise over run is slope, or we take the difference in the y's, y2 minus y1 over the change in the x's, x2 minus x1, and the abbreviation or representation for slope is lowercase m. Right, so here we got the Cog Railway, covers about 3.1 miles and gains about 3,600 feet of altitude. What's the average slope of the track? So it's going 3.1 miles and rising 3,600 feet. So you got a train going up the track, right? 3,600 feet up and 3.1 miles across. So our slope is rise over run. Since we don't have any x's or y's, we can't do the y2 minus y1 over x2 minus x1. So we're just doing the rise over the run, which the rise is 3,600 feet, and the run is 3.1 miles. Now, what's wrong with this equation, the way it's set up right there? All right, we got two different measurements, right? We got feet and miles, so we need to have them either both in feet or both in miles. And so I'm going to change the 3.1 miles to feet. So anybody know the conversion? 1 mile equals, nobody? 5,200. 5,280 feet. And so we're going to convert the 3.1 miles to feet. So 1 mile and 5,280 goes on top. So units we want to get rid of go top and bottom. So now we got 3.1 times 5,280. That will be 16,368 feet. So now we can rewrite the slope equation. 3,600 feet over 16,368 feet. So the feet will cancel each other out. And 3,600 over 16,368 will be 0.22. All right. So then, next up, we're going to find the slope of a line that passes through the points -3, 0, and 4, 7. All right, so if we look at these as x1, y1, and x2, y2, then our slope, or lowercase m, represents slope. It's going to be y2 minus y1, so 7 minus 0, over x2 minus x1, so 4 minus -3. That's going to be 7 over 7. for a slope of 1. So just changing the y's over the change in the x's. Just make sure that it really doesn't matter which one you pick as x1, y1, or which one's x2, y2, as long as whichever you put first in your subtraction, it goes with the same one from its coordinate in the front. Alright, so then postulate 17, slopes of parallel lines in a coordinate plane. Two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. So if we know they're vertical, then they're automatically parallel. Otherwise, in order for them to be parallel, they've got to have the same slope. So if the slope's the same, they're parallel. If it's not, they're not. Questions there so far, anybody? Like I said, this is really just a algebra review. So here I want to find the slope of each line and then determine is the slope of, or is line M1 parallel to M2. Alright, so let's identify the points that are on here, which is -1, 4, -4, -3, 2, -1, and 3, 1. So, of course, if it's on a graph, kind of makes it pretty easy to do the slope. If you want to do it this way, you can see that it's going from -4, -3 to the right 3. Right, so it's 3 over and up 1, 2, 3, 4, 5, 6, 7. So we do rise over run. The slope of 1 is 7/3. And for the other one, going over 1 and up 2, right? So 1, 2. That's 2 over 1, or simply 2. So 7/3 and 2. 7/3 is 2 1/3, so they're close, but the slopes are not exactly the same. And so they are not parallel. Because they have different slopes, right? Right, next one, line P passes through 0, -3, and 1, -2. Q passes through 5, 4, and -4, -4, and line R passes through -6, -1, and 3, 7. Find the slope of each line. Which lines are parallel? All right, so start off by finding the slope of each line. So P, which has 0, -3, and 1, -2 as its points. The slope of P is going to be -2 minus -3, the difference in the y's, over 1 minus 0. So double negative becomes positive. -2 plus 3 is 1, and 1 minus 0 is 1. So the slope of P is 1. And then Q uses the points 5, 4, and -4, -4. So finding the slope of Q We got negative 4 minus 4 over negative 4 minus 5. It's going to give us negative 8 over negative 9. Or double negatives. Makes that a positive 8/9. And then lastly, R, which goes through negative 6, negative 1, and 3, 7. And so the slope of R is going to be 7 minus negative 1 over 3 minus negative 6. So both those are double negatives, become positives. 7 plus 1 is 8. 3 plus 6 is 9. So 8/9. So the lines that have the same slope are the ones that are parallel. So that would be that Q is parallel to R, since they both have a slope of 8/9. Questions there, anybody? So far it's just using the slope formula, and if the slopes are the same, they're parallel. Alright, so then switching a little bit, writing the equation of parallel lines, because we know if two lines are parallel, they've got the same slope, and so you've got the slope-intercept form of an equation, y equals mx plus b. That formula should be ingrained in your brain after algebra. All right, m being the slope, and the b is your y-intercept where it crosses the y-axis. And so I'm going to write an equation of a line through the point 4, 9 and has a slope of negative 2. So starting off, the slope is negative 2. So the m portion of our equation is going to be negative 2. And then we've got the point 49 as part of it. The thing we don't have is a y-intercept. We don't know where it's crossing the y-axis. We don't know what the b is. So we're going to take all the parts that we have, the slope, which is the m, plug it in. We're going to use the point 49 as our x and y values, and plug in all of that so that the only variable we have left is the y-intercept, the b, so we can figure out what that b value is. So from here, using y equals mx plus b, plugging everything in, y is 9, m is negative 2, the x is 4, and the b is what we don't know. It's going to be 9 equals negative 8 plus b. And add the 8 to both sides. So our b value is 17. And now that we know what the b value is, now we can take our slope, m equals negative 2, and our b value, and put those together to make the equation. So y equals m, which is negative 2, times x, plus the b value, which is 17. Questions on that one? Solve for b, and then you just plug in the m and the b into the equation. Alright, so line K has the equation 2/5 x plus 3. Line L is parallel to K and passes through the point negative 5, 0. Write an equation of L. Alright, so since it tells us that they are parallel, we know that they have to have the same slope, right? And so the slope for k is the m value in front of the x, which is 2/5. So we know our slope of L is going to be the same. It's going to be 2/5. And then it's going through the point -5, 0. And so now that we've used the equation of k to figure out the slope, and we've got a point, now we can go through this just like we did the last one. All right, so plug in the parts that we know to solve for the y-intercept. So using y equals mx plus b, our y is 0, our m is 2/5, x is -5, and b is what we're trying to solve for. So 0 is going to equal 2/5 times -5 is going to be -2 plus b. Add the 2 to both sides, and our b value, or our y-intercept, is 2. So take the y-intercept and the slope and make the equation y equals m, which is 2/5, times x plus b, which is 2. All right. Next one, a line goes through the points 3, 2, and -5, 4. Give the equation of the line. Okay, so in this one, we don't have a y-intercept given to us, and we don't have the slope. So we do have 2 points though, so we can figure out the slope. All right, so take our 2 points, plug it into the slope formula. So 4 minus 2 over -5 minus 3. That'll be 2 over -8, or that'll reduce to -1/4 for our slope. And then we can solve for the y-intercept just like we did before. We got 2 points to choose from. It doesn't matter which one we pick. Right. So I'm just going to go with the first one, 3, 2. So if we use that point and the slope of -1/4, then when we plug it into y equals mx plus b to solve for the b, we're going to have a y of 2 equals -1/4 the slope times the x, which is 3, plus b. So 2 equals -3/4 plus b. So we can add 3/4 to both sides. And so we've got 2 3/4 equals b. But we want to convert that into a improper fraction. We don't want to do a mixed fraction into the equation. So 4 times 2 is 8, plus 3 is going to be 11/4 for our b value. So now we've got our b, we've got our slope m. So y equals our slope, -1/4 x, plus the b value, which is 11/4. One more line goes to the points -7, 2, and 3, -4. Give the equation of the line. So same basic kind of setup and problem. First thing we'll do is figure out the slope. So negative 4 minus 2 over 3 minus negative 7. Negative 4 minus 2 is negative 6. 3 minus negative 7 will be 3 plus 7, which is going to be, or not 9, 10. So negative 6/6, which would reduce to negative 3/5 for our slope. And then, just like before, pick a point. Actually, I want to go with the other one just because the numbers are smaller. So then plug those in. So the y equals mx plus b format. Our y is negative 4. Slope of negative 3/5 times our x, which is 3, plus b. So it's going to be negative 4 equals negative 9/5 plus b. And we add the 9/5 to both sides. Get a little more complicated because we're going to do negative 4 plus 9/5 equals our b. So in order to deal with these, we need a common denominator, so we need a 5 on the bottom of the negative 4. So multiply top and bottom by 5, so we get negative 20/5 plus 9/5 to get our b value, which negative 20 plus 9 is negative 11/5. Be our b value. So now we take our b with our slope, plug them into the y equals mx plus b, so y equals m negative 3/5 times x plus b, which is actually a negative, so we're going to say minus 11/5. Alright, so that's 3.6 notes.